Our next speaker, Tin Marković, will now have a talk. Please give him a round of applause.
Hello, ladies and gentlemen. I am Tin Marković, and I'll be talking about refactoring in Python, patterns and approaches. This clicker doesn't seem to work. It's okay. So, what's refactoring? What is the point of my talk? What's the story behind it? Imagine yourself being in a situation where you get hired to a new job. You get hired to work at a startup company that you know has grown big, that has multiplied hundreds of times since its conception, and now you've been hired as a software consultant or a senior engineer or a team lead or whichever, and you need to help employees improve their process, help them work better, and help them improve their company to grow further. And as you enter and as you see the code, you see that it's horrible, that it's very hard to work with, that people have problems making the simplest of changes, and that it needs serious work. However, with some experience in the technology, some experience in the industry, you know that 90% of the current developers would like to write it back from scratch. And the investors don't want it. The managers don't want it. Nobody wants to start everything from zero because it's uncertain, it's dangerous, and it could ruin the company. So you have to do it well, you have to do it step by step, and you cannot just throw everything away and start from zero. That's where refactoring comes in, that's where parallel developing comes in, and developing features side by side with fixing the old things. I'm going to talk about that today. First things first, I am Tin. I am a team leader at Kiwi.com. We are something called a startup, although not really. You can find our booth outside. I'll get back to it in a moment. I like to work with software. I like to design software, to get big mental maps into my head. I like to work on complicated systems, so the role at Kiwi was a perfect fit. I had experiences working with other big Python projects, for example, edX, and it's usually always problematic, and it always comes with baggage. And I try to share the same patterns through all the work I do, because it's always the same. It's always a step at a time. My company is Kiwi.com. I'm not going to keep long at this slide. You have our stand outside. Basically, what's important is that our stack is Python mostly, with some friends here and there, some other platforms thrown in. We're focused on tech because all our business goes through interlining flights virtually, so it's mostly automatic and online. And we are focused on making travel better. The abstract of the topic is how to read the old code, how to keep working with the old code and improve it to a modern standard, to a better standard. It's also about the principle called the Chesterton's fence. It's a Wikipedia coined principle that says that you should not be allowed to remove a fence or any element without first knowing why it was put there. For some people, some features, some parts may seem without sense, but then you remove them and everything breaks, because you just didn't understand what you were working with. It's important to be measured when doing big changes, especially when throwing away big things. And I'm going also to touch to some testing, dependencies, systems, and relationship, how the writing tests and how problems writing tests are symptomatic of the quality of your code base, how they display how good your code is. If you can easily write tests, that means you're in a perfect place. I'm not going to go into too much detail about tests. Many talks have been had, and my colleague will also have a talk this afternoon about writing tests. I'm also not going to go into details with some software patterns. A lot of talks have been there, and tools also. Most people just talk about these simple elements, but rarely they put them all together. I'm going to try to put it all into a workflow that can be applied to a company or a project. The overview of the talk is going to be general topics, but specific examples. I'm going to cover it through 3 chapters or topics: the easy wins, the patterns and anti-patterns, and the philosophy behind it all. And I'm going to try to provide specific examples. I'm going to try to provide how we are doing it at Kiwi.com and how we are trying to fix it overall. So, easy wins. What are easy wins? Easy wins are, by definition, easy. There are things you can do in a day or 2 that will increase your quality of life. There are small fix-ups that can help you work every day, but they don't solve the root cause. They don't fix your code base. They don't prevent problems. They're just there to help you get to the end. They're mostly plugins, libraries, utilities, software you can run that can help you work with your code. Most of these are about automated code quality. There are tools that will check your code, see where you've made mistakes, where you don't follow standards, and they work on their own. What's important about this is that you can put all decision saving to a single meeting, to a single discussion. You can have all the time you would spend arguing about code standards, decided once, then enforce automatically. These tools are, for example, PyLint, MyPy, Black, and Koala. How many of you have heard of Black? It's good. Koala? So yeah, not so many people. We will go over all of these with some basic examples just to show you how cool these tools are. My aim would be considered fulfilled if like 50% of you started using Black after this talk. Just an example. Hopefully you will take more than that. Let's start with the basics first. PyLint and MyPy are some of the standard tools that many code bases in Python use. The problem is that they usually don't automate them, but we'll get to that later. PyLint is a linter. It just checks your code statically according to the rules it has set up. Then it corrects you when you make mistakes, warns you when you have risky code, etc. It gives you a list of things you could look into and check in your code to fix. It's a pretty established industry practice, and the only problem is that people don't automate it, so it tends to build up. You tend to fix up all your problems with PyLint, then new ones appear in a month. I recommend everybody has a linter in their integration, in their continuous integration on GitLab or GitHub, and it will increase code quality by a lot. MyPy is similar to a sense that it's also static, but it requires some integration. It requires annotations that will simulate typing in Python. What the thing is with MyPy is that it's completely optional. It's opt-in on a per function basis. That means that you can start using it just for a couple of functions that you know are cleanly written. Then you have the rest of the code that's pretty chaotic and not annotated, and MyPy will not crash you because of that. It will just do the annotated parts. So it's easy to implement it slowly, to implement it on a function per function, and integrate it step by step. It doesn't need to be this huge hackathon where you spend a couple of days integrating, typing into your code. You can start little. Black is a code styler that we use at Kiwi and that I've seen be used in many more and more companies worldwide working in Python. It's a super simple styler that doesn't allow you to configure more than 2 or 3 flags. It's run and it styles everything automatically and syntactically, which is important. It doesn't do style as much as syntax. For lists, it breaks everything by elements rather than alignment. It doesn't allow arguments to be aligned vertically, etc. It's a very useful tool, and the most important thing is that it removes the arguments. It removes discussions about unimportant things like white space and line breaks. And what's wonderful about it is that it keeps the same interpreter output. It doesn't modify your code in any way. So you have a guarantee that your code that was run before Black and that is run after Black will run the same identical way. Then Koala is a set of tools that's a bit more advanced and requires a bit more greasework. It's very modular. It's full of these Koala bears that are different tools in the industry focused into a small package that then you plug into Koala and it runs all the tests for you. It also has the capability to automatically fix some of these tests. And what I found wonderful is that its complexity checks work well. It's great to use locally. This is a simple example. I'm not sure if it shows that well, but it shows some made-up code, how it looks before and after running these tools. First of the examples is just that the arguments are fixed to a new line, that typing is introduced, that it forces you to write docstrings because some of these integration tools will fail without docstrings, and it also removes unnecessary things via keywords. For example, we do not allow printing in our code base, so it will block your code until you remove all prints and replace them with logging. It also requires for all code paths to return something, to be explicit. The conclusion is that these tools will make your day better. Day-to-day programming will be easier to do. It will be less conflicted, less discussions, less problems, and you will be able to focus on thinking about problems and fixing the overall code base rather than thinking about line breaks, single line changes, etc. It's an easy bump in code quality, but it's just a bump. It doesn't fix the core issues. That's why you need to go into deeper into your code to see why it's hard to use. Why is your code surprising you? Why is it not what you expect, and why are changes hard to make? Why does everything break when you change 5 lines? That's mostly because your code breaks what's called the principle of least astonishment. Things you would expect from your code base are not so. They are different. They'll use a print, your custom underscore print, and it changes some state in the function. It changes some flag, and now everything is not the same. And all you've done is printed a thing, etc. Legacy code is often astonishing. Legacy code often surprises you, and you spend hours debugging something to figure out it's completely different than what you've expected. And when you complain to somebody, they'll just tell you historical reasons. Somebody else did it that way, now we just carry on. And code like that is usually organically grown. People just write code, and it happens that it gets reused and reused and reused, and some bad anti-patterns come into it. What you can do is distinguish these code smells. Those are like red flags that you notice in code that show you this part does not work that well. And then you can go on to see why. It's usually because of neglect, inconsistency, redundancy. You see repeated code, you see inconsistencies, you see code that should have been deleted years ago even, but you notice that nobody has fixed it. And it usually happens because of these things, because of deadlines, because of quick prototyping, some top priority requests, something needed to be released yesterday, so people just rushed to get a minimum out there. But the rest hasn't been cleaned up. There was no time to stand back and just look over it and start cleaning it. That's where you use code smells, the flags that you start recognizing, and you figure out which parts are broken and which parts are creating trouble for the future. There are some levels of these. You can start from easy to medium to hard. Basically, they go in scope. Easy ones can be fixed in place. You don't have to worry about them. There's almost no scope. Medium ones are architecture mistakes. They are things that you know can be done better, but they will require the team to stop and to start rewriting something larger. They usually also respawn, so to say, because people will have these code patterns there. They will see how it's done, and they will repeat it even if it's wrong. That's how most junior developers work. They see a problem, they find in your code base a solution to that problem, and they try to emulate it. They learn from the code base. And in some cases, that's not such a good thing. Some code bases have a lot of older code, a lot of non-optimal code, and people tend to repeat it because it's there, because they can just reuse whatever's been used before. And then you have the hard smells, the ones that are easy to notice. Everybody sees that it's bad, but it's almost impossible to remove. They are usually the reason why whole teams and companies go to rewrite everything. They want to just change everything back and start from zero. Some examples are just a piling up of different conditions. For example, here, some airlines and their currencies. We have some airlines that we have only a single currency with. And in this code, part of code, at the start, it was just a single condition. Then another developer came and had to fix it, added another condition. This list grew up to be much larger than these 3 ifs. But at the start, it was just a couple of ifs, and it grew, and nobody took the time to stop and rewrite it into something more sensible. It's easy, it's in place, you can just do it via dictionary or something else. It's not a big problem, but it's hard to look at, and people just need to do some maintenance. Then you have the medium thing that we used to have were orders and similar keywords that would do huge things. They were functions that would take request, rename to data, and do a lot of things with it. Here you can see that the order method verifies additional order data and payment, then stores it. But that doesn't explain a lot. How does it verify it? What does it verify? Why does it take just a dictionary, and why does it return a dictionary? There were many mysteries in it, and every developer had to go through it line by line to figure out what does this huge method do. And that was a problem that we are still, to this day, rewriting and fixing slowly. But those are the medium scope. You know it's wrong, but it's fixable. Then you have the hard ones, which is a huge code base that doesn't use ORMs at all. We've managed to implement an ORM, SQL Alchemy, because SQL Alchemy is relatively easy to implement as it doesn't have its own methodology. It's just an extension to using SQL as SQL. But usually these hard problems like implementing a framework or removing a framework or changing a version of a framework make you want to start from the beginning. And that's usually very hard and demanding. As a tool, I would mention SonarQube, which also does static analysis of code, but on a whole another level. It analyzes all that we've mentioned before, some bugs, code smells. It also has a database of security oversights. It also analyzes your tests for coverage, complexity, to check how well those tests integrate. And it reads your comments and documents. And it all has all of it with explanations, and it comments it all in your code repository, in your Git. So it's a pretty great tool. And what's the highlight of SonarQube is that it explains every single alert it does with an explanation and some examples, which is pretty great when you're working with code as a junior and you don't know why is this flagged red, why is this a problem. You see an example, you see some extra text to explain what you're doing wrong, and it helps you learn a lot. After identifying them, you need to start working with these anti-patterns to somehow remove them from code. You need to cover them first to try to neutralize their effect, then you need to remove them eventually. As I've said, it mostly comes from organic code growth and copy-paste coding. It happens because people just write code rather than stop and think about it. It's for mostly a problem of startups and smaller companies that don't have a strong architectural decision. They don't have the budget of time and money to have somebody sit down for a week and decide what's the application going to look like. And usually they don't have the benefit of having a defined product in advance. They grow fast and adapt to whatever happens. That's normal, but somebody also needs to clean up after. These are some anti-patterns we've had at Kiwi that I've identified here and there. For example, some of those are the magical methods, as I call them. They're methods that lack explicit input and output. This is pretty standard everywhere. It's the side effects most people dread. And usually these methods use a lot of side effects, for example, to clean up your application after running something. They are usually replaced by a better object-oriented approach, by starting to separate concerns a bit more strict, to start to clean up things, and to start to be more explicit rather than implicit. But they're usually a problem for people who come to your company or to your team to see this magical method used everywhere that just doesn't fit in the picture without you reading every line of the code. You see that it's a cleaner method, but it breaks if you don't mock a database. Why? And you figure out it reads from the database even though it's supposed to not, etc. We also had problems with decorators being a bit abused. Modifying the function signature. Decorators should not modify function signature unless you have a really, really good reason. They should be explicit and do a single thing really well. They should not also replace method calls, and here you can see 5 decorators on a function that just returns user details. And it goes from out to logging to formatting responses, many complicated things that shouldn't be put above every single function. They should be done via middleware, they should be done via just regular function calls or exception handlers. They shouldn't really be decorators. In our case, they were. We still have functions that have 5+ decorators. Slowly getting there. I would recommend these things get tackled by building bubbles in code, so to call them. Code can be a big ball of mud. It can be a big interconnected mess. That messy code is then harder to maintain and even harder to test. You cannot really test something that will break on 6 different places, and testing doesn't really make sense if you have to mock 20 different things before calling a simple function. You need to start separating concerns and isolating different elements, which can be hard to do overall. That's why you should try to isolate smaller segments and start testing those, creating these reliable bubbles that will help you figure out the concerns, figure out what you can, and start working on it. The most important part is that you start with these smaller parts, then let it organically grow out and connect with each other. After some time, you have these code bases that you can call your new and old, and it makes all the difference to know that you've started somewhere. You didn't just maintain the old mess, but you've had these bubbles of clean code. And it mostly can be done by implementing some separation patterns. That allows you to separate the older and the newer code, and those separation patterns are mostly interfaces and facades. We'll get to them in a moment. But they separate older code from newer code via strictly, explicitly defined borderlines that then help you identify what should call what and why does it do it in the old code at all. An interface, I'm not talking about the Java interface pattern. It's more of a general term where you'll just find an interface for a part of your business logic. You'll find common usages of a code pattern and common method names and calls that should go on as an interface would in a stricter language. Then when you find this base use case, you create it as a baseline. You just go and create the order when all goes well. You don't go and do the refund order and etc. in the same code. You don't do different cases. You just create this base interface. And then you add edge cases to implementation. It's pretty much just object-oriented code, but you need to do it part by part. You cannot start with it all being designed. Then you have the facade, an inverted facade, so to call. You need to wrap your code in classes and in modules that wrap it with special calls, that wrap it in special function signatures that fit both sides of the code. If your old code is based on calling many functions and creating pipelines, and you want to approach it in an object-oriented way, then you have to do a facade that will just create the object and use it in a single function. Why go through this trouble? It's to keep the required side effects there, but to make them obvious, to make it obvious that you're adapting to the older code and that it shouldn't be done this way and ideally shouldn't be this way. And sometimes it's hacky, but it helps you manage this required functionality in one place. It helps you have all the interfacing between older and newer code in a single module or a single set of files that tomorrow you will see and can cross through and say, we need to change this method to be implemented natively without this facade. We need to change this and this. It helps you implement a contract that you can see there, and it shows you how it ideally should look like. It shows you how you want the code base to look like, but currently you cannot achieve it yet. It's an important step to go into implementing newer design patterns into older, messier code. And it also helps with testing. If you have these made-up methods, you can usually test them much better if they use your class-oriented approach. And testing is very useful. It's worth all the effort because it brings you confidence with code. It brings you the ability to change things, knowing if they'll break something. And the unit tests, integration tests, smoke tests, they're all pretty great. But it's important to test without making it a charade, making it useless and just wasting time on it. Usually when your code is a mess, testing can be pretty useless. If you mock everything you're using, if you literally do tests to pass through mocks and not assert anything, you're just wasting time, and that's a lie. A lot of people get bad experiences while trying to write tests. A lot of people I've heard of that call testing time wasting haven't tried to test properly, haven't had an opportunity to do it in a real code base. That's why side effects should be minimized so you can test better. And code should be refactored, so tomorrow when you want to write a test, that code goes rather smoothly. The test is written in a couple of minutes, and you don't have to worry about mocking everything in your application. They're just a guide to quality. They're like, if you follow principles that will help you write better tests, then you're usually writing better code. And personally, I would go with a reverse list than here. I would first try to write some smoke tests, tests that will blow up in case your application doesn't do the basics. They do the happy paths. Then the integration tests that will integrate a couple of bigger modules here and there. And at the end, unit tests. Unit tests are a luxury more than a necessity, even though the internet is blown up about unit tests being super important. Integration tests are more worth it for your time. Basically, the conclusion is that after wild growth, code is almost never pretty. It's almost never optimal, and almost nobody likes it. But then after you grow, you cannot throw everything away anymore. Now you've got a company that needs to continue working, that needs to continue growing, and you need to improve gradually. You need to build these bubbles of clean code, bubbles that you can test, places that you can work with, then slowly grow on and expand to the whole code base and to the whole product eventually. Now, those are the easy parts, the code one. The problem is that you're not a one person, you're not a one-man show usually, and you need to implement this over the whole team. So that theory is good, but getting there is even better. You need to establish some rules and you need to enforce them, otherwise people will not follow them. People will just break whatever they see, they will just figure out I can do this quick hack, and it will just slow down things again. And it's also important to realize that the cost-benefit analysis is for everyone. Everybody needs to figure out when they can spare time to fix things and when they cannot, and what to enforce and what not to. So the first thing is to approach this whole problem, all the problems, slowly, because rapid changes don't help stability. Throwing everything out will just break your whole product. These policies and these rules need to be implemented step by step, so people don't rebel, so that people don't get stressed, and so everybody can adapt to better workflows. It's just important to keep the pressure there. And one of the highest and best improvements you can get is to enforce code review. It's just requiring people to read each other's code, and it's more about knowledge exchange and code quality than anything else. It's not there to be super strict, so people can block each other's and create problems. It's more so everybody knows what everybody is doing, so people can audit each other. And continuous integration is great. I do not have time to go into details about continuous integration, but there are many talks, and you should research it, definitely. And if you require it to pass, you're halfway there already. You also should split responsibility in some factor. It matters to you. It's about an organization where even the reviewer needs to know that he is responsible to review with quality, that he needs to see the code and understand it, because tomorrow he'll be called to fix it too. It's about reducing the buzz factor, so not a single person has developed a whole part of the application and they're the only one who can read it, the only one who can understand it. In KiwiCom, we enforce all of this via continuous integration. We do not allow anything to be merged if it doesn't pass review, and in some cases we require even 2 people to review code before it enters the code base. Some best practices with code review, and it's important to keep code review blameless and impersonal. You should never have a person be called out for their code. They should not be personal. When you review code, you review the code. You don't call out a person for being stupid, incompetent, or something similar. You just improve the code they've written by suggesting changes, that this can be written better, this can be improved by reading this book, this article will explain why this part of code is not so good, this will be worked on better if you try to approach with this in mind, etc. Basically, it requires people to look at code, not at other people. It's sometimes hard, especially in smaller teams, but it's a step that really has to happen. And then I would also suggest that code reviews go through a triple tier system, because otherwise you have people review many things, then you fix them all, then they request changes that break everything, and then you have to fix again, and you have a code review just drag on and on. That's a big opposition to adopting mandatory code review, is that it extends things. If you just go top down, it's much shorter and it wastes much less time. For example, you start with the overall scope, you check if the problem is solved by this implementation, if the implementation is trying to grasp the issue, and if it fixes it. Then you look at the system scope. You see if that fits into overall engineering picture, if it fits the idea for the company, for the software, how it should work. And after all, you then go to the code scope and you check small code changes. Basically, you don't check single line code until you're sure that function signatures fit, the objects fit, the whole image fits itself, and then you can work on the code, and you will not request a person to fix 5 typos just to delete them later. Then it's very important to have education up to level. The devs need to understand why are they working on something and how they're working on something. You need to enforce better documentation before and after changes. Even when you don't fix a big function, if you don't clean it up, you need to enforce people to write down their understanding. If somebody has this monolithic foobar function that does 90% of the business logic, but has 0 documentation, you can just enforce people to write down something when they pass through it. You enforce this via reviews and CI, and you just tell them, that, hey, you've edited this big function, and obviously you know what you're doing, but write it down for the rest of us. So we know why you changed line 70 and 71 and how it makes sense in the big picture. And if people start writing down notes here and there, more people will catch up and people will communicate through code comments and through reviews rather than just make believe and in person and you have 3 people who know the whole structure but they decide to quit and your company can fail. We do it via having in-house talks. We have an education budget that we send people to conferences. Even this conference was funded for some people. We also try to promote public discourse where questions should always be asked in public channels for Slack. And there should be minimum of talking around private messages and in person when it relies to tech. And everything should be summarized in public. We also are starting to grow our tech writing culture where we have people who are dedicated to writing better documentation and checking up on us. And it helps. It helps to have everything written down, to have documentation there, to know why a part of an application is like it is. There's also no easy victory here. There's no quick success. Wins are each a step, and the quality will increase slowly. You cannot replace proper engineering and proper engineering culture via any tools or any policies. It needs to come step by step and to be accepted by everyone. We also try to focus on our product in Kiwi. We work on long-term success rather than quick wins. And we have allocated time to work on fixing the code, which helps everyone. It helps the general efficiency. There also needs to be knowledge of that code is written to be replaced. That best code can be thrown away easily and quickly, and that less dependent code is better. That microservices are popular because they enforce this in a more tangible way. It doesn't have to be microservice architecture. It helps, but it doesn't have to be. And by allowing easy reuse, by allowing easy replacement, you also allow easy reuse. If something can be quickly tossed out, that means it can be quickly integrated, and then you can work with it much easier if it breaks, or if it needs replacing, or if it needs rewriting. We also enforce that by forcing an MVP culture somewhat, where we try to get things to start rolling, to start working, and then later we integrate them to the product. So by definition, it should all be easy to remove as well. And yeah, sometimes it requires explaining how does the code depth hurt. You have management that will not really understand it. You have people you need to put the point through. Basically, you explain that eventually things will crash down because mistakes will happen more, implementation will slow down. Basically, you will require more time to fix everything, and it will slow down, and nobody will be happy because you have these small changes that take weeks. We try to minimize micromanagement, in Kiwi at least, where you're allowed to clean up behind yourself before you switch to a new project. You don't have to validate every single minute of every of your days. As long as you work for the betterment, it's okay. And yeah, you need to counteract management every now and then. You have to convince them why is it worth it to spend time to fix things. And the best examples are the ones that caused losses for the company. If you have a failed release, if you have a bug that happened, you need to learn to blame the code depth and not the developers. Mistakes happen for everyone, and everybody can make mistakes. And we do it via our blameless environment. A dev can never be blamed if he didn't intentionally break something. If it's not malicious and intentional, there is no blame attached to any mistake. Mistakes happen. And the conclusion is that the low quality code that happens is usually a symptom, and it needs to be handled at the basis of it, at the cause, step by step. It needs to be fixed consistently, slowly, to help you build a better product in the end, and to slowly take it on. There's no easy win. There's not a burst that can happen and make everybody's life easier. It's a slow, tedious process that just requires everybody to go on every day. The conclusion is that old code tells a story. That story, that product needs to modernize. It cannot just disappear. You cannot rewrite it usually. You should grab the easy boosts when you can. You should implement all these tools if you have an option, especially linters and static code checkers. You should grab those easy boosts. Then you should try to rewrite whatever failure there is in code in bubbles to start testing at least a little. It cannot be done overall. And then you should do quality going forward. You should maintain it. You should enforce some simple principles that will make your developers happier, that will make your teams happier, and that will make everybody just more productive. Thank you for your attention. I guess we'll go through the questions now. What's the difference between PyLint with and without plugins and SonarQube? The thing is, PyLint is better in what it does in its own light. It's quick, it's clean, it does minimum interference in your code, it can be run locally, while SonarQube is a more weighty tool. It does most of that and extra. But it's a larger product, it needs to be set up, it needs to be given specific permissions, and it needs to check your code more in depth, and it takes longer. Basically, PyLint is good at that one thing, while SonarQube is a whole framework and a system that also does a part of PyLint's job. We try to. Sometimes it's hard, sometimes it's, I should read it out, yeah. Do you put facades in front of your dependencies in order to be able to easily change the dependency or its version later on? We try to. We try to wrap most things in our custom interface that fits the use case. Logging, etc., should be done in a repeatable way. But sometimes it's very hard. For example, with database management tools, it requires a lot of abstraction to have them interchangeable. We didn't take that leap yet, but with tools that we know can be changed, we try to always wrap them in some kind of a handler, in some kind of a wrapper, so we can plug it in and out. Basically, what happens with facades once the code base is refactored? Are they replaced with other design patterns that better fit the use case now that the legacy is gone? Basically, you have these new design patterns already written. The facades are just the intermediary step to allow those shinier design patterns, those better written code to implement with the older code. When you move through it, the facade is no longer needed. You just plug it in natively. You don't write you don't write a layer in between to adapt it, because if you're doing it correctly, you will not need to adapt anything. You just natively support it. Which tool do you use for writing documentation? Where do you write the docs? We keep documentation in many different places. I think automated documentation is written via Sphinx. And everything else is docstrings mostly, and Markdown. We keep documentation close to code, and by doing that, you can just write it yourself or read it there. And we try to keep the minimum separation of documentation as an entity and code as an entity. We try to keep it really close. And how do you feel about YAPF? I have no idea what YAPF is. I didn't try it, personally. That's it. Thank you for your attention.
Hello, I was invited here from my company and through my company, TV.com, and I'm joined as a technical speaker for PyCon Belgrade, PyCon Balkan in Belgrade. I was here before at meetups, and I really enjoyed the city, I enjoyed the atmosphere, I enjoyed the people and the whole environment of new technical startups, new companies, new organizations. There's a lot of inspiration around, and it just feels good to be a part of it all.